In today's notes, we're going to take a look at graphing linear inequalities in the coordinate plane. The first star at the top of the page says graph the line just like you would if it were an equal sign. So it's still going to be in the form y equals mx plus b. It's just instead of the equal sign, you'll see the inequality symbol. If you have a less than or equal to or a greater than or equal to, the key part of both of those symbols is the equal to. Okay, if you have one of those symbols, then your line's going to be solid. If you don't have that equal to symbol or part of the symbol, then you're going to use a dotted line. Now, all the solutions to a linear equation were on the line itself. With an inequality, the solutions are on either side of the line. So if you have the first bullet, if you have a greater than or equal to, both being greater than, you will shade above. If you have a less than or equal to, you will shade below this line. Okay? We can talk about where to shade according to the symbol, but I really like to just check or verify the solution set by picking a point from the shaded area to see if it makes the inequality true. And the easiest point to test is 0, 0, because anything times 0 is 0, and the math itself is just easier. In the box, a linear inequality describes an area, okay, as we just talked about, or a region of the coordinate plane separated by your boundary line. Each point on a dashed line is not a solution. Okay? If it's on the dashed line, because the line is dashed, it's not including all of those points on the line, but we need that boundary to identify where the solution set is. If the line is solid, okay, then each point is a solution. So let's take a look at some examples. The first one's pretty easy. So we graph it as if it was y equals 3, and y equals 3 is a horizontal line passing through an intercept, a y-intercept of 3. Because of the equal to part of the symbol, it is going to be solid. So that would be right here. Here's y equals 3. But we want, oh, I'm sorry, it's y equals negative 3. We're down below. Okay? That includes the equal to part. Those are all the values equal to negative 3, but we also need to include all of those values greater than negative 3. So all the values greater than negative 3 would be above. So we shade. And we shade just by drawing lines. Okay? Not by actually shading in like this, because then we wouldn't be able to see the graph behind it. We just draw some lines. And we label. So this is y greater than or equal to a negative 3. So if we wanted to test those values, let's take a point here. If I wanted to test that, that's the point 2, 1. Is that y value 2, 1? So is 1 greater than or equal to negative 3? Yes. You can try another one, 0, 4. Is that y value greater than or equal to negative 3? Yes. So there's the solution set to that inequality, graphed in the coordinate plane. The next one, y is greater than negative 1/2 x plus 1. It's always good to note your slope and intercept anytime you're graphing these, just as you would a straight line, so we can get you some partial credit if you make a mistake. The line itself, because it doesn't have the equal to symbol, is going to be dotted. So we're not going to be including those points. And we're going to shade for greater than above. But I'm just going to reinforce with testing a point to reinforce that concept. So our slope of negative 1/2, y-intercept of 1. So we plot the y-intercept and we use the slope to move. So down 1 over 2, down 1 over 2, down 1 over 2. So go ahead. You have enough points to sketch that line. I'm just going to continue going. up 1 over 2, up 1 over 2. Now line up your straight edge, and the line along your ruler is dotted. And we need to be able to see that it's dotted. Okay, so I might go back and make sure that looks to be separated. Now, greater than is above. So above the line when it's dotted, or when it's slanted rather, is here. And I'm going to test to make sure I shaded the correct solution set. So I'm going to test the point 0, 3. So if I'm testing 0, 3, I'm going to plug in 3 for y. Is 3 greater than negative 1/2 times x, which is 0, plus 1? Well, this is 0. Negative 1/2 times 0 is 0, and 0 plus 1 is 1. 3 is greater than 1, check. So if I had tested, say, 0, 0, for instance, the origin, is 0 greater than negative 1/2 times 0 plus 1? We get 0 again for that product, plus 1 is 1. 0 is not greater than 1. That's false. So any place you test in the solution set, you should get a true statement. And any point you test that's not in that shaded area or your solution set should come out to be false. So I'm just going to finish by labeling y greater than negative 1/2 x plus 1. And then last one, number 3. Well, before we can graph, it needs to be in the form y equals or y is greater than or equal to, less than or equal to, so on and so forth. So I'm going to solve this for y. I'm going to start by moving the 3x over. We have negative 5y greater than or equal to. I'm going to put it in the y equals mx plus b form. So the x terms first. And then dividing by negative 5, we have to remember to reverse that inequality symbol when dividing by a negative. So that greater than or equal to becomes less than or equal to. It has to reverse directions. We can't divide 3 by 5, but a negative over a negative is a positive. And then bring down your x. And then 10 divided by negative 5 is a negative 2. So we have a slope of 3/5 and an y-intercept of negative 2. So at negative 2, I'm going to put a point. And I'm going to use the slope of up 3 over 5. So up 1, 2, 3 over 1, 2, 3, 4, 5. Down 1, 2, 3, left 1, 2, 3, 4, 5. Now let's talk about the line. Going back to the symbol, because of that equal to, we're including all those points on the line and then below it because less than. So on for equal to and below. So we can use a solid line. So line up your ruler. Okay. You may want to label before you shade. So this is 3x. We label with the original inequality. 3x minus 5y is greater than or equal to 10. And then shade. That way you can go around the equation that you wrote instead of having to write it diagonally. Just to check or test, let's test the point 0, negative 5 right here. Let me grab a different color. 0, negative 5. So if I test 0, negative 5, it should come out to be true. If I tested 0, 0, it would have come out to be false. All right, so is 3 times 0 minus 5 times negative 5 greater than or equal to 10? This is 0. Negative 5 times 5 is a positive 25. And 25 plus 0 is 25, which is greater than or equal to 10. It works. On the back side, now we're going to be writing the inequality from a graph. And there's a star that says this is very similar to writing the equation of a line, which is in the form y equals mx plus b. It's just now our equal sign is going to be greater than or equal to, less than or equal to, or just greater than or less than. So the first thing we do is make note of our m and b. Okay, find the y-intercept, find the slope. If it's a dotted line, then it's going to have the less than or greater than, so no equal to. And if it's a solid line, it will have that equal to, because we are including all the points on that line. So let's take a look at the first example. The y-intercept is right here, so that's a b value of 1. And now I'm going to count the slope. You want to make notes of all those points on the line that are right in the corner of your grid, and that looks to be down 2 over 1, down 2 over 1, down 2 over 1. So we have a slope of, again, change of y over change of x, negative 2 over 1 would be negative 2. This line is dotted, and we're shading below, okay? So since it's dotted, we're not going to have that equal to. And since we're shading below, that must mean less than. And we can always check to make sure we're right. So our inequality is y less than, so mx plus b. Okay, and I'm going to check, this time I can check 0, 0 because it is in the solution. So if I test 0, 0, we can make sure that we're right. Is 0 less than negative 2 times 0 plus 1? Well, negative 2 times 0 is 0, and 0 plus 1 is 1, and 0 is less than that. We are right. Next one. Note our m and b. We have a y-intercept of 3, and then a slope of, let's see, our next point looks to be here. So let's down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So negative 5/4. This is a solid line, okay? And we're shading above. Okay, so in y equals mx plus b, the inequality symbol, well, since it's solid, it's going to have the equal to, and above is going to be greater than. And I'm going to test the point 3, 3 to see if we're right. Is 3 greater than or equal to negative 5/4 times 3 plus 3? So 3, is that greater than or equal to negative 5/4 times 3 is negative 3.75, and then add the 3 to that. We get 3 is greater than or equal to negative 0.75. It checks. So we are correct in our inequality that we wrote. Last page, system. So that means we're going to be graphing more than one, okay? And it's a linear system of inequalities, so they're going to be lines. The first thing you want to do is graph each inequality. Remember your dotted, solid, and where you need to shade. And then the solution set for both, we're going to label with a capital S. Okay, this is where the two shaded areas overlap. So it's good to use different colors, and it's kind of fun too. And then we're going to check. And then a solution to that system is any point in that shaded overlap, okay, or that solution set. So let's take a look at the first one. It's pretty easy. It's x greater than or equal to 3 and y less than 2. So let's go down to the graph. I'm going to do x greater than or equal to 3 in green, okay? And that's going to be because of the equal to a solid line. So x equals 3 is a vertical. So I'm going to draw the vertical line through an x-intercept of 3. And that is solid because it's equal to. So it's all the points that are on that line and greater than. Greater than's to the right. So I'm going to label first x greater than or equal to 3. And then I'm going to shade. The next one I'll do in orange. Y less than, no equal to, so that means this is going to be dotted. And y equals negative 2 is a horizontal line, so I'm going to draw a horizontal line dotted. Okay, and all those y values less than are below. So I'm going to label this first, y less than negative 2. And then I'm going to shade. So I'm going to shade in the other direction. Okay, and that overlap, let's use this blue, is the solution set for both. Okay, so if I test a point in that solution set, let's test for -4, this point right here. Is the 4, here's your x and here's your y, so is 4 greater than or equal to 3? Check. And then plug in the y value. Is -4 less than -2? It is. Last one, and I'll graph them in the same colors. The first one is already in the form y equals mx plus b, so our slope is 2 and our y-intercept is -5. This is going to be dotted because it doesn't have the equal to, so it doesn't include the points on that line. So starting at -5, a slope of 2 would be up 2 over 1, up 2 over 1, and then it's dotted. So line up your ruler. Okay, take a look when you're done to make sure it looks dotted. I'm actually going to make a break right here after this point to make it clear that it's dotted. And then greater than is going to be shaded above. Well, above here is where? Okay, is it to the left or is it to the right? So in this case, you may want to test 0, 0. Is 0 greater than 2 times 0 minus 5? Well, this is 0, and 0 is greater than 0 minus 5 is a -5. That works. So greater than, when it's slanted in this direction, is over here. So this worked out to be true, so that's where you want to shade. I'm going to label that area y greater than 2x minus 5 and continue to draw my lines. All right, last one. I need to solve it for y, so I'm going to move it over here. 3x plus 4y is less than 12. Well, I guess I'm going to graph this one in pink. Subtract 3x. 4y is less than -3x plus 12. Divide by 4. And y is less than -3/4, since we can't divide 3 by 4. X plus and 12 divided by 4 is 3. This is also going to be dotted because it doesn't have the equal to, so it does not include all the points on the line. Our slope is -3/4, and our y-intercept is 3. So starting at 3, we're going to go down 3 over 4. Down 1, 2, 3 over 1, 2, 3, 4. I can go up 1, 2, 3 over 1, 2, 3, 4 to get that third point. And then this line is going to be dotted as well. So drawing the dotted line, giving a quick glance to make sure it does look dotted. Good. And then shading below is going to be here. And I'm going to label it. Since there's nothing here, I'm going to put it here. 3x plus 4y. Doesn't matter where you label it, just as long as it's below the line. And then the overlap with, in this case, the pink and the green is right here. So I'm going to put a big S for that solution set. And the point that I'm going to test is 0, 0, because that's the easiest one to test. And we know it worked for the green. So we need to make sure, because that's really the check for the first one right there. So now I need to check. When you check, you need to plug it into both. So there's the check for that one, and then is 3 times 0 plus 4 times 0 less than 12. 0 plus 0 is 0. And the sum of 0 is less than 12.